Welcome. In this video, we will cover Chapter 13, Part 3, where we will discuss automobile emissions. Automobile emissions are also a significant contributor to air pollution. Most automobiles work through the combustion of gasoline. Gasoline is a fraction of oil that contains the hydrocarbons from carbon length 5 to carbon length 12. When gasoline burns in a combustion engine, these carbon-carbon bonds break, and the energy from the carbon-carbon bonds and the carbon-hydrogen bonds is harnessed by the engine and utilized for movement. One example of a carbon-based compound in gasoline would be octane. Here is the combustion reaction of octane. Octane has the formula C8-octa C8H18. Two molecules of liquid octane can combust and react with 25 molecules of oxygen. The carbon from the octane ends up as carbon dioxide, which is a gas, and the hydrogens from the octane end up as water in its gaseous form as well. These are the products from the combustion reaction of octane. The carbon dioxide and the gaseous water are released from the exhaust of the car. When there's not enough oxygen available for the complete combustion of the carbon, carbon monoxide can form instead of carbon dioxide. Vehicles are the leading producer of carbon monoxide emissions worldwide. Carbon monoxide is much more dangerous than carbon dioxide. It is not only toxic, but it's extremely difficult to detect. It's colorless, odorless, and tasteless. In order to understand why carbon monoxide is so dangerous, let's take a little bit more of a look at the structure of carbon monoxide and how oxygen bonds to hemoglobin. Hemoglobin is naturally found in your blood. The purpose of hemoglobin is to transport oxygen throughout your bloodstream and your body so that the different organs can obtain the oxygen that they need. Hemoglobin contains an iron, and the iron binds to the oxygen. This acts as a transporter for the oxygen in the blood. The way carbon monoxide poisoning works is that the carbon of the carbon monoxide covalently binds to the iron. This prevents the hemoglobin from transporting any oxygen molecules. Carbon monoxide poisoning essentially leads to a suffocation because your body can no longer access any of the oxygen that you're breathing in. If you recall, we looked at a reaction where nitrogen can combine with oxygen in the atmosphere using the heat for lightning to form nitrogen oxides. Nitrogen oxides can also be produced within the combustion engine due to the high temperatures that exist. This is the same reaction where we have a molecule of nitrogen reacting with a molecule of oxygen to form two molecules of nitrogen oxide. It can then be oxidized to nitrogen dioxide, which is also an acid anhydride and can lead to acid rain. In general, nitrogen monoxide and nitrogen dioxides can react with water in the atmosphere to form nitrous and nitric acids. These lead to not only acid rain, but also increased smog formations and serious lung complications as a health hazard. Combustion of gasoline can also release volatile organic compounds. These are all the compounds that are small molecules based of hydrocarbon that aren't in the gas phase. Various technologies have been developed to reduce the emissions from automobiles. For example, the catalytic converter, which was developed in the 90s, reduces the hydrocarbons and carbon monoxide emissions from automobiles. and this is required on newly made combustion engines. There's also a large shift towards the use of battery-operated electric vehicles, which don't utilize gasoline or a combustion engine at all. If we look here at the pH scale, we can see right at 7 is neutral. Pure rain comes at right around 5.6. Anything more acidic than 5.6 is considered to be acid rain. Acid rain has a variety of negative effects on both nature and humans. Issues may range from negative health effects to difficulties with plants, as well as decomposition of man-made structures. Indoor air pollution can be an even larger problem than outdoor air pollution because of the confined space indoors. The EPA estimates that sometimes the levels of pollutants indoors can range 2 to 100 times higher than the levels outdoors. The pollutants indoors come from a variety of sources, including gas kitchen stoves, cigarette smoking, and kerosene heaters. These devices also are able to release carbon monoxide and nitrogen oxides. Especially in Florida, mold can be a huge concern. Anywhere that moisture exists, mold can grow. This is extremely abundant in bathrooms and kitchens. The mold spores can lead to a variety of negative health effects, such as asthma, bronchitis, and other lung diseases. It's been known for a long time now that cigarette smoking can lead to cancer. Cigarettes have hundreds of different chemicals within them, and at least 40 of them are known to be carcinogenic or lead to cancer. The EPA considers secondhand smoke to be a Class A carcinogen, and regular exposure to smoking indoors can lead to increased risk for heart disease, lung cancer, miscarriages, and sudden infant death syndrome.